Good morning or good afternoon, depending on where you're calling in from. My name is Mary Napolitano, and I'm going to be speaking to you this morning about LinacView, which is an effortless machine quality assurance for every fraction of every treatment. So I want to let everyone know that today's webinar will be recorded. If you have to step out briefly, you will be sent a copy of the recording after the webinar. At the end of the webinar, or at any time, questions may be entered in the GoToMeeting dialog box, and they will be addressed at the end of the presentation. So to give you a little background about Standard Imaging, we are based in Middleton, Wisconsin, and Standard Imaging was founded in 1989, so we recently had our 30th anniversary. And Standard Imaging designs and manufactures a full suite of QA products here in Middleton, Wisconsin. And this is a photo of the office taken a few days ago, so we have a good amount of snow here on the ground. I'll give you a brief overview of LinacView, and then I'll do a brief software demo. So to begin with, I'll go through the workflow of LinacView. So one would start with your treatment planning system, do an RT plan export through your record and verify to the Linac, and then at the same time, you would do an export of the RT plan to LinacView. Once the plan is delivered and the log files are acquired by LinacView through a synchronization system, LinacView goes ahead and automatically associates the log files with the RT plans that have already been retrieved by LinacView at the time of the TPS export. And so one can do pre-treatment QA analysis, of course, if the plan is exported and delivered before the patient arrives, and also during treatment QA comparisons for every fraction of every patient treatment. And then there's a mechanism where you go ahead and put in your tolerances, and you will receive audible or email alerts from the system as soon as the patient delivery is complete and the log files are received by LinacView. So for a particular patient, that would usually be before the patient has even left the clinic. And then afterwards, you can go ahead and you can analyze for a particular session and acquire an RT plan that you can put back in your treatment planning system if there were variations that occurred during the particular treatment. Or after all of the fractions are delivered, you can create a summary plan of the entire session and feed that back into your treatment planning system if you do get any alerts or failures. So just a review of this typical workflow on a per plan basis. Approve the prescription, send the RT plan to LinacView, export to an RT plan folder that is being monitored by the LinacView computer. You can, of course, send your RT plan to a different second check. You can send your RT plan to the record and verify as soon as the plan is delivered. LinacView is always monitoring for the log files and then associating with the plan. So that's your typical workflow. And for example, if you had many Linacs at a particular clinic, then you could be monitoring all the deliveries from all of these Linacs. And this Linac in particular has had an alert. That alert can be seen either as an email that is set up to go to the physicist, or at the treatment console, you can set up an audible alert. So there are two levels of QA with LinacView. The clinically relevant QA, which is primarily based on fluence comparisons between the RT plan, fluence calculation, and the log file calculated fluence. And then you can also compare and review for the particular plan, plan-specific monitor unit, gantry, collimator angles, etc. And so for these clinically relevant plans, you can set LinacView up to send alerts so that immediate action can be taken. And then in general, you can also have general machine performance review. So you can go ahead and look retrospectively and review your carriage, jaws, leaves, table positions, monitor units, and just use that to predict future maintenance requirements. And this sort of workflow does not generate any automatic alerts. Another interesting feature that I mentioned briefly is the summary of the RT plans. So once you have delivered all of your fractions for a particular patient, you will have log files that LinacView has analyzed, and then LinacView can create an average RT plan with the actual delivered control points, monitor units, leaf and jaw positions, and then this can be sent back to your treatment planning system so that you can review the actual delivered plan as reported by the log files and compare that to the RT plan that was initially generated by the treatment planning system. And all major treatment planning systems have been tested. So LinacView has currently had a new release a couple of weeks ago, and the new features for this release are log files from plans delivered on Elekta Linacs. Now will work with the automatic field sequencing, and it will associate appropriately with the RT plans. So that's a nice new feature because most people like to deliver using AFS. The second new feature that's even more exciting is the Elekta Unity support. And you might ask, why is LinacView useful for Elekta Unity? Well, if you're familiar with the Unity, it's an adaptive workflow. And so in an adaptive workflow, you have limited QA options for your per plan treatments. So you couldn't possibly do a pre-treatment QA because each plan is optimized and created while the patient is on the table. And so each fraction is like a new plan. The physicists could not possibly keep up with measuring each new patient plan every day. And of course, independent QA is desired as it's a new workflow using a new platform. And now I'll provide a brief software demo, but I wanted to give you some background about where we're starting with the demo. So at the time when the demo will start, you will have exported, or I will have exported, pretending to have exported an RT plan from the treatment planning system, and also exported to the Linac. And I will start the demo when pretending like the Linac log files are coming into LinacView. Okay? And so let me bring that up now. And so what you're seeing here is this warning on the screen is merely telling the user that you have lost connectivity with the Linac. And since clearly I don't have a Linac here in the office, it's just giving me an alert that I am no longer monitoring the log files coming from the Linac. And so right now the batch dashboard is blank. Because we don't have any plans that have been analyzed. But I'll go ahead and I will pretend like I'm beaming on the Linac, and we're going to deliver 5 fractions almost instantaneously because I can do that, not in the real world. And so these are the various fractions coming in from multiple different dates, and then it's analyzing. And this is how quickly LinacView can analyze. So it's picked up 1, 2, 3, 4, 5, 6 days worth of treatments, and it's had analyzed them in just a few moments. And then I will just go ahead and pick up one of these. You can see that because this is demo data, we had all failures because, of course, except for this one, because we want to have something to look at for the demo. But this is not a common occurrence in today's Linux. You will rarely see a failure or an alert, depending on how you set your specifications for pass, alert, and fail. So I'll go ahead and load this particular session, the first one, and then I'll bring it in because we want to, of course, come and see what happened to this particular file. And so what you can see are the 6 different sessions. And you can see we had one pass because everything's color coded, green for pass, this orangish color for alert, and red for fail. So we'll look in on the first session. And what you can see is a nice summary up in this area. And you can see that the integrated fluent map comparison versus the planned is passing with the gamma index of 99.9%. You can see next that the gantry RMS error is 0.1, so it passed. Where we're having our alert is with the gantry maximum variation. It's at 0.5 degrees. And then we can also see that the RMS error for the collimator passed as well as the maximum. And then if you want to go down into this section, again, it's color coded. And in this area are your alert and fail parameters if you want to check those. So we have green all the way down. And then, of course, in this area, we're seeing some leaf variation. And then the jaw gantry maximum that was 0.5. And so what I will do next, you can either load the entire session or you can load a particular treatment. And I will load a particular treatment. And then it brings you again to this summary page where you can just through the color coding with your eye quickly review all of the areas. And then we can go ahead, we can look at the jaws, the carriage summary. We can look at the integrated plan comparison. And so you can see in this area that we don't have any gamma failures. I believe I loaded the whole session rather than the individual plan, but you can do either and we can go back and review again. We can look at the gantry and you can see this area that I pointed out to begin with. We are over the 0.5 alert that has been set up for this particular session. And then you can look, of course, at the collimator review. I'm going to go back and then I'm going to, let's see. Look at the analysis a bit more. And for that particular plan, we can look at the dynamic view because you can't look at the dynamic view for the entire average plan clearly. And so what you can see in this view is on the left is the log file display, and on the right is the RT plan calculated fluence. And up in this area, once I start the playback, you can watch the gantry angle and the collimator angle, and this designates when the beam is on and off as read from the log file. So I'll go ahead and push play. And what you can see as the plan progresses, there are some portions where the particular leaves are showing alerts and a few failures here and there. But typically for just one or two leaves, you won't see an overall plan failure unless, of course, it's set up to send you alerts, because you're really concerned with a larger portion of leaves being in the fail or alert level. And so that pretty much concludes my software demo portion. There are a lot of things you can go in and review in a plan by plan and segment by segment basis for the plan. And I already mentioned the gantry angle deviation. You can go in and look at it, and you can go in and review many details for your plan, including a lot of leaf-specific information, the RMS error for each particular leaf bank, the maximum, the RMS errors. Just you can go in and dig and see a lot of information about how your plan was actually delivered. And so with that, I will return to the PowerPoint presentation for just a moment to summarize. So in summary, you have real-time log file monitoring for every patient with no impact on patient workflow. Therapists can see dashboard results in real time during treatment. That's if you have your Linac computer set up in the console area. The physicist can receive automatic email alerts for any significant issues based on how you've set up your parameters and your preferences in the software. And so you have automatic machine performance analysis for each fraction of every patient. And it's easy IMRT VMAT QA fluence comparisons. And now I'll check and see if we have any questions that have come in. And I don't see any questions. And so I'll give you a moment if anyone wants to type in a question. Otherwise, we'll just conclude the webinar for today. All right, well, thank you very much for attending, and we look forward to you joining us on future webinars. Have a great day.